All right, we're back. So we talked on the last video about what we call that indeterminate method. Indeterminate. I don't know what it is. What's indeterminate? I don't know what it means. That's literally what it says. If somebody asks you, what's the definition of indeterminate? You can actually say, I don't know, because then you'd be absolutely right. Indeterminate method are what happens if we get 0 over 0 or infinity over infinity. And that's what we're going to talk about right now. So if we take a look, in the factor cancel method, we will use algebra to cancel out the common factors in the numerator and the denominator in the fraction. You may recall from algebra and pre-cal, this was the same method we used to determine the location of a whole in a rational function. So now we're starting to relate limits to what you did last year in your pre-cal class. So the first thing we're going to do is we are going to try to plug in 4. Now if I plug 4 in the bottom here, I get 0. Now but you got to be careful. It has to be 0 over 0. Anything over 0 can be an undefined. It could be a vertical asymptote. We specifically need 0 over 0. If we don't get one of those, then it's a different method. We'll talk about that later. But if I plug 4 on the top here, I'm also going to get 16 minus 4, which is 12, minus 12, which is also 0. Now notice how I'm writing it. I'm never going to write 0 over 0. We don't write this. AP doesn't like that. Even though we know what you mean, it is improper to say it. So we never write 0 over 0, but they are okay with this method. So we get 0 over 0. Now normally anytime you get 0 over 0, what this is really saying is that we have a common factor. We have a common factor. Because I got 0 on top, I got 0 on bottom. The only way that this can occur is if one of them, if there is a factor on top and a factor on bottom, that both are 0. It'd be like saying 0 times 3 over 0 times 4. The only way we get 0 over 0 is if we have a common factor that is 0 that we can cancel out. So that's what we're going to do. We are going to factor the limit as x approaches 4. The bottom already factored for me. And the top, well, if the bottom is 0 at 4, I probably can tell you one of the top factors is x minus 4. And I get x plus 3. And yeah, look, those x minus 4s cancel. Now here's the part you're really not going to like. You have to write the limit. We are still doing a limit. If you don't write the limit here, you're saying that the value exists. And we already know right here that the value does not exist. That's what this 0 over 0 means, that there is no value at that point. So we have to write the limit every single time. If you don't write the limit, you would be wrong. You're saying that the value exists. Because remember, what we're really saying is, what are we approaching? We're approaching a whole. In this case right here, think about pre-cal, like right here. From pre-cal, you said that this was a whole. So you can't have a value at a whole, which is why we need a limit. But if I now plug in the 4, I get 4 plus 3, which is 7. So therefore we can say that the limit as x approaches 4 of our function is now 7. Now, again, from pre-cal, what this is really saying in the graph is that there is a hole at the point 4, 7. Now, if you don't have the limit here, you're saying that the value exists. You can't have a value at a hole. So we have to be very careful. You need the limit here and here. Okay? You need to keep writing the limit until you can just substitute in. And that's very big for us. Okay? So let's try the next one right here. Ready? If I plug in, let's change this 3 to a 2. That should be a 2 right there. Let's make sure we change that. On the top, we're going to get 0. On the bottom, 2 cubed is just 8. 8 minus 8 is 0. So again, it's indeterminate. Again, what this is telling us is that the value does not exist. So because the value does not exist, we can't use that substitution method. So we have to use another method. And the method we use, we can factor. That is a difference of cubes. So let's review that. if I have a cubed minus b cubed, right, that's just going to be a minus b, right? A squared plus ab plus b squared, right? And if I have a cubed plus b cubed, that's a plus b, a cubed minus ab plus b squared. Your difference in sum of cubes, so in case you forgot those. All right, so for the top one right up here, if I rewrite this, now again, the value does not exist, so I have to write the word limit as x approaches 2 of x minus 2. If I factor the bottom using my rule, I'm going to get x minus 2, x squared plus 2x plus 2 squared, which is 4, right there. And again, the tops cancel, like we already said. If I get 0, 0, one of them is going to cancel. And what I'm left with, I'm going to write this left, the limit as x approaches 2 of 1 over x squared plus 2x plus 4. And I can just plug in the 2. 1 over 4 plus 4 plus 4, or 1/12. Therefore, the limit as x approaches 2 of my function is 1/12. And again, we're not saying that the value is 1/10. We're saying that we're approaching 1/12. Remember, this is saying we are approaching, or that f of x is approaching 1/12. It will never reach it. Why not? Because it does not exist. And again, that's from pre-cal. Because pre-cal, you might remember, is that if the factors cancel, that's telling us we have a hole at x equals 2. And now we can actually find the location of that hole. Right there. Right? Remember, this is saying there's a hole at 2 and 1/12. There lies a hole. All right. So let's try number 3 here real quickly. Again, if I plug in 0, 2 to the 0 is 1. 1 minus 1 is 0. Notice I never write 0 over 0. Bad math. Plug in 0 here, 1 minus 1, again, that's 0. So again, this is indeterminate. Again, this is saying that the value does not exist. We can't use substitution. Remember, substitution, if you remember, says if the value exists, I can just plug it in. It'd be the same. The limit is the same as the value. That's continuity. But here we're saying that the value does not exist. So when we plug in, so now we have to factor this. It's the only other technique we know. We'll talk other techniques tomorrow. So we'll see the limit as x approaches 0. The top I can't factor, but let's see if we can remember how to factor the bottom. Yeah, that's just a difference of squares. That's just 2 to the x plus 1, 2 to the x minus 1. How's that for a difference of squares, right? And if I plug in, those cancel out. So again, from pre-cal, we are saying that this is a hole, which is why the value did not exist. Now, do I know what this graph looks like? I do not, but I know there's a hole now. And I can even find where that hole is by finishing up my limit. The limit as x approaches 0, 1 over 2 to the x plus 1. And I go 1 over 2 to the 0 plus 1, which is 1/2. So therefore, I can now say that the limit as x approaches 0 of my function is 1/2. And again, what this is saying is that there's a hole at 0, 1/2 from pre-cal. Again, we're not saying the value. Notice, I don't say equals 1/2. I say the limit equals 1/2. Because if you just put down 1/2, are you talking about the value? Are you talking about the limit? Are you talking about how many points you're going to get on this? If you don't write the limit, we don't know. So we have to put the limit here because we know the value does not exist. We are approaching 1/2. That's what this reads as. And that's how we want to have it. All right, the other method we're going to talk about today is very similar to the factor cancel method. And that is called the conjugate method. Not conjugal, that's prison talk. All right, so conjugate method. This is used when a radical is involved. Okay, very simple. You'll recognize this right away. In this situation, we multiply the numerator and the denominator by the conjugate. You might remember conjugates from last year in pre-cal, right? If you have a conjugate, right, if you have a plus b, the conjugate would be a minus b. Basically, the conjugate sets up a difference of squares. Okay? Now, I know what y'all thinking. Mr. Werner, last year we learned we never rationalize the numerator. We only rationalize the denominator. That is not true. We actually, the only time we ever really use rationalizing is really to rationalize the numerator, not the bottom. And that's what we're going to do here. So the first thing we have to do is we have to make sure substitution fails. Remember, again, substitution has to fail for these methods to use. Otherwise, just use substitution and just plug in your answer. If I plug the 4 on bottom, again, I get 0. If I plug the 4 on top, I get 2 minus 2 equals 0. Be very careful. I want to tell you guys something. The square root of 4 is 2. Okay? The square root of 4 is not plus or minus 2. And that is not true. The square root of 4 is always a positive 2. Be very careful. The plus or minus comes from as if you take a square root. Like if I solve here. If I square root, we get, you might remember this from Algebra 2, the absolute value of x is 2. And that plus or minus comes from the x. The plus or minus comes from the unknown, the absolute value. That's how we get our plus or minus right here. But the square root of 4 is always 2. We'll talk a lot about this throughout the year because I can see some of you guys shaking your heads. That's not what my 8th grade teacher told me. Okay? We'll talk a lot about that throughout the year. Alright, so if I get 0 over 0, my rule, use the conjugate method. So we get the square root of x minus 2 over x minus 4. We're going to conjugate the numerator, not the denominator. Square root of x plus 2. Use parentheses, of course. Make sure you have your parentheses. I will mark it wrong if you don't have parentheses, okay? And if I solve this, again, I take the limit as x approaches 4. On the numerator, that's just our difference of squares. So I know that's just going to become x minus 4. Up on the bottom, there's my x minus 4. Notice, I'm not going to distribute the bottom because what's going to cancel? That's right. The x minus 4 is the square root of x plus 2. And I'm going to get now, those cancel. We're left with the limit as x approaches 4, 1 over the square root of x plus 2. And that becomes 1/4. So therefore, I write my answer. The limit as x approaches 4 of my function is 1/4. Now, be very careful when you write. Remember this. This is saying here, again, that the value does not exist. So we know the value does not exist, but what are we approaching? Okay? All right. Here's a great question from the AP a couple of years ago. They asked people to solve this limit right here. So many people got it wrong because they tried to use the conjugate method because they didn't substitute first. Always do what? Substitute. That's right. If I plug it in, I get the square root of 3 minus the square root of 3 over 3 plus 3. I get 0 on top, but on bottom I get 6. This is not indeterminate. So therefore my answer is just 0. So I can say my limit as x approaches 3 of the function is 0. That is not a method for us. That is just plain old substitution because I get a number. 0 is a number. You can have 0 over 6. And later on we're going to say we can even have 6 over 0. That becomes asymptotic. We'll talk about that I think on Friday of this week, okay? Later on this week, sorry. Alright, so you guys have fun. Work on the homework. I'll see you guys tomorrow. Bye.